Good morning. My book reading summary, Stephen Hawking's Black Holes. This is a very small booklet. It's only of 69 pages, but it's quite in depth. So it took me a little time to reread it and understand the actual context of it. So in 2016, Professor Stephen Hawking delivered the BBC Reith lectures on a subject that has fascinated him for decades, that is the black holes. And in these flagship lectures, the legendary physicist argues that if we could only understand black holes and how they challenge the very nature of space and time, we could unlock the secrets of the universe. So, according to Life Science in 1974, Hawking proposed that black holes eventually evaporate by losing what's now known as Hawking radiation, a gradual draining of energy in the form of light particles that spring up around black holes, is immensely powerful gravitational fields. So, Stephen Hawking actually predicted in 1974 that black holes died by evaporation. But experts thought the extreme gravitational environments of black holes were unique to his theory. A new study said that Hawking radiation, which kills black holes, could also kill everything else. So I went a little further because this is quite deep. So I went a little further and read some research on that in bbvaopenmind.com and summarized it in simple language. So, in the mind of the public, black holes are often imagined as huge cosmic vacuum cleaners that suck up everything in their path, including light. This is an evocative but incorrect idea. A black hole is not and does not create a vacuum, but quite the opposite. It attracts through the effect of gravity because the density of its mass is so enormous. It follows that we should have nothing to fear if the sun were to be replaced by a black hole of the same mass. Though our world would be much colder and darker, the planets would continue to orbit undisturbed because the mass of the black hole would be equivalent to that of the sun. The existence of black holes stems from the theory of general relativity published by Albert Einstein in 1915 and the subsequent work of Robert Oppenheimer, Carl Schwarzschild, and Subramanian Chandrasekhar, and others. Space and time form a fabric that is curved by mass, like a trampoline. A black hole is a ball so heavy that it has at its center a singularity, a region so infinitely dense that it collapses the bottomless trampoline. So, this has been my understanding from what I have read in this book. And yes, these black holes are often called stellar black holes as well. They originate after the death of a star whose internal gas pressure pushing outwards can no longer counteract the enormous force of gravity, which compresses its remaining matter until it collapses into a black hole, a couple of dozen times the mass of the sun. So these are tiny compared to those that can store up to millions of solar masses. The supermassive ones that sit at the center of many galaxies, at the other extreme, there are black holes even tinier than the stellar ones, micro black holes formed in the early universe. Regardless of their size, they are all surrounded by an invisible boundary called the event horizon. The discoveries of Stephen Hawking shone light on the darkness of black holes, but at the same time raised questions. This is what NASA has to say. And the visualization simulates the appearance of a black hole where infalling matter has collected into a thin hot structure called an accretion disk, and this is done through a event horizon telescope collaboration. The soft hair black holes, the so called information paradox, has remained the most important of the questions raised by Hawkins' works. So, in the opinion of Maltazina, this question has kept physicists busy for the last half century, including Hawking himself, who until his death searched tirelessly for a theory capable of unifying general relativity and quantum mechanics. In other words, a quantum theory of gravity that describes what happens inside black holes. And in Stephen Hawking's last works proposed a solution to information retrieval in the 1970s. John Wheeler, who popularized the term black hole, and Jacob Bekenstein claimed that black holes have no hair, in the sense that the only properties a black hole could have were its mass, its electric charge, and its angular momentum. So, this was my learning and the summary from the book. And this is not the summary completely written by me, it is an understanding from the book, my personal understanding from the book, and some that I did the reading on the internet as well, because this book is quite in depth. So we need to go over the book more than once to understand the actual meaning of the book and what Stephen Hawking was conveying through his lecture. So this is about it. Thank you.